then terminate sea level rise at about that level, then the sedimentation will take over and you get another progradation event giving rise to what you see here, and then you have the package, in this case two power sequences, where you've got a posting upwards and another posting upwards cycle, and this surface then represents the rapid deepening that occurs when the sea level change is relatively rapid. Yeah, it's true. If things are balanced, then that won't occur, obviously. So when sea level rise ceases for whatever reason, whatever causes the rise in the first place, a new power sequence will develop and prograde out over the initial power sequence in an attempt to fill the newly generated accommodation space. Scale is important here, obviously. Power sequences can be deposited over tens to thousands of square kilometers. Obviously, this is in part going to be controlled by the nature and geometry of the sedimentary basin, the geometry in a geographic sense, not necessarily in a cross-section sense. And the other thing to remember, of course, is that power sequences contain a record of a variety of environments of deposition. Okay, so if we look, we've got two power sequences here, and in this particular power sequence, we are dealing with a shoreline type set of environments, offshore, shore face, foreshore, backshore environments. Here we've got another power sequence that is related to deltaic deposition. So within these packages of sediment that form in these different settings, you can have significant changes in the larger environmental picture. So kind of a coastal beach type setting here and a deltaic setting. And if you think about that, if you go from the Brazos River mouth and come along the shore towards Galveston, the power sequence sets that are forming in those two settings will have represented in the sediment accumulation there significantly different environments of deposition. So with time and variations in sea level changes, you get power sequence sets forming. Retrogradational power sequence sets will form when you have the fairly rapid rise of sea level that overwhelms the sediment supply, and then you backfill it with progradational packages when sea level stabilizes, or the rate of sedimentation is changed, increased for some reason. Because this is always a balancing act between sediment supply and accommodation space development. So the diagram that we see there, and this thing right here, shows the effect of power sequence sets developing where you have retrogradational packages. And what you see happening here is this geometry that you see developed here is related to the fact that you have a series of sea level changes, rises in this case, relative sea level rises, of different magnitudes. And as those magnitudes increase, obviously you develop this retrogradational sediment set. This also is a product of retrogradation, but here you've got a fairly uniform rise in sea level, giving rise to, again, a retrogradational stratigraphic package, but it looks somewhat different from the one on the left, simply because the one variable that we're looking at here, sea level change, is not uniform in that diagram, it's uniform in this setting here. And this gets back, I think, to your question. I'm not sure that it does, but you will get aggregational power sequence sets developed when the sedimentation rate roughly matches the sea level change that we see in this diagram. So in this case, obviously, the shoreline does move significantly, and that's the definition of an aggregation sequence only. And this shows an aggregational sequence set over some period of time where we have intervals sea level rise that is roughly matched by the sediment supply. Again, the point here is that the shoreline, which is marked somewhere around here, essentially remains in place. And then we get back to the point that we were making earlier. Progradational power sequence sets will form when the supply of sediment outstrips the rise of sea level. And again, the thickness of the power sequence sets will in part be related to the change of sea level and the rate of sediment supply. Here we see on the right-hand side a sequence of events where we have a different progradational geometry, slightly different progradational geometry related to different sea level changes. When you don't, here we've got a situation where we have significant progradation where there is no change in sea level. This is what sometimes I think is referred to as a depositional regression, because the supply of sediment pushes the shoreline seaward. You have a similar effect here with progradation, but in this case we have a lowering sea level in addition to the oversupply of sediment, as it were. And when the accommodation space decreases because of the fall in sea level, which is what we're seeing here, that's what's referred to as a force regression that was asked about earlier. So you've got the two kinds of regression here. You've got the depositional regression and the force regression. Okay, it's sometimes called a normal regression, yeah.
Like taking a big
looks like what?
But taking a big is not close. Like progradation taking a
Well, I mean, progradation exists to the extent that as the sea level drops, I mean, the shoreline has to go with it. I mean, it has no choice in that sense. But so the shoreline is moving seaward, which is the definition of a regression, and what we're saying is this is a forced regression because of the sea level, relative sea level change. This example, the shoreline also moves seaward, and so it's a true regression, but it is the product of the effect of deposition, and hence the term depositional regression is sometimes applied to it. Okay, so the force regression is independent of sediment supply. It's related purely to the lowering of sea level, because conceivably you could have a lowering of sea level where you had a very poor source of sediment back there and you're not supplying much sediment anyway. The regression still occurs. In this lower one? I'm not sure where you get the aggregational package there. Oh, okay, yeah. And the other thing that happens, of course, in this aspect of the post-regression, the shoreline moves to a lower level on the depositional profile in this particular situation. Okay, let me stop there and we'll continue from there on Monday. I was looking at my calendar earlier today and I noticed that I had on the 27th, which is a week from tonight, I guess, we have the third short quiz. And that will cover material from conservative plate margins through, let's make it through material that we covered on Monday. So stuff that we've covered tonight will be on quiz 4. Okay?